你就记得
他就退了。
8点还有2点，快点快点走。真的？
先要讨论讲打完的。
这样。永远平凡哎。给他玩，我操！我可能给不了了。遇到了这一家。写错了。我看后来第4题要读出来了，然后那个我要发誓。
后面去也是他。小地图 ，SMUN 小地图。
对。
这不是 iPhone？ 对。对。啊？
发现11要关掉了。
别留字词。
导致我要听掉别人歌。
为什么？啊，更恶心了，理性的。
跟着你们不是。要不没快。流行。我觉得有嘞，我想点。他就有一感觉就是厉害。它是一个那个。
什么？对。啊。没有，是这里那个喷的。
现在你，因为就是在对那些表的机器。
没有，他们有一个 lab， 他们有一个 lab。
哦，真的，等一下，就要来了，最后会参加一次见面才是嘛？来的，那就别的。因为你不参加，就是那天3个店嘛，就来的，那就别的。等一下，他来说了，来走。白水生，每个也是。另外，老师看草饭，都睡觉了。我们那个东西，不可以不要讨论。
什么？
大炒饭。
没有看到一个影片是说你要喂什么叫蛋炒饭？我跟你讲鸡生蛋还是蛋生鸡？蛋炒饭有什么好讨论？
蛋炒饭还是饭
？I think
我不要保留我的 brand。
应该是蛋奶炒的饭吗？
还是口没甜甜？
我觉得蛋炒饭重点是饭。饭炒蛋的话，应该就蛋比较多，饭比较少。 就1比1哦，少过1哦。啊？
就是靠感觉。
哦，我觉得不可以喧宾夺主。
它就是 SD 或者是 S 多的哇。
我觉得跟个人口味有关系，个人口味。
跟后面继续 PPT。没有错，你要给我拿，你知道吗？可以，这就可以干嘛？对吧？你不懂，我不懂，你就不懂啊！不管是谁的钱，都可以发出去，没有发给你吃，没有发给那个人，是啊，连 ID 都生出了。别人组织是消防的，这是我挺好吃。确实，他考试了，那几个 AI 就在哪里？
累啊，要们 CS 做到。
没有，我是找到几个简单也是。
对，因为我们 post 在哪里啊？Family 啊，
这是我第一次
我的什么？
那个不是我啊，还是我的，一个理解是你是。我的希望。没有啊，这没有啊，那边没有，我在那里不喜欢啊。我这边那边的，哎，这鱼河，我没拿到，我这，其实你跟我说，你要知道是什么。
哎，那天我给那个 abstract 呢，没有被放出来哦，有没？我的 abstract 没有，
你放进哪里了？
我放那没有 abstract。
放弃有点水。
Teams 的版本有？没有，好像没有出现。
是吧？
我们准时开始对吧？我们准时开始，提早结束，提早结束。喂，hello，hello。7点半呢，我们开始了。K，哎，他们想问一下，那全部2年 T 都是其他 C，啊 CST 我知道你，
不来申请，S M，才会的。
可以了，全部 MLT 还是 OK。如果你们要听的话，你们可以坐近一点，对呀，就靠近一点，比较容易讲话，比较容易说给你。坐近一点，坐近一点。 before 我介绍我自己啊，should I converse in English or Mandarin 呢？English 啊？English 啊？You like English better？哦，不会华语，OK，
其实我也是快60了。
什么？
就是声音很性感。
看到 English 啊，OK，因为我的 master 学生在那边。So， 还有人进来。Okay, good. Okay. So basically today, who am I? I'm Keesing. Okay. I was invited by MAT Student Council here to do some sharing, not necessarily on these topics. Okay, actually I don't prepare for these topics also. But then I have something to share to especially MAT students, especially why I come back after my study. Yeah, what's my role here? Not very serious, but then we do a kind of relaxed atmosphere here. It's not like because you already study for the whole day, right? Yeah, I will just finish my 3 hours lecture, very tired. So maybe share some philosophy or what's my view on maths. Hopefully it's helpful for you to go through your 3 years programs here, so that you don't get too exhausted, because this is how people come through all these 3 years journey. Yeah, 3-4 years journey here. Maybe I can ask, what's your motivation here? Can I ask what's your motivation here? Why you come here? Because I'm concerned. What's your motivation here? 你觉得我很好玩？数学好玩还是我很好玩？数学好玩。数学好玩。OK。还有呢？Size your mind. Any different answer? Huh? What?
This is study group.
You always here. Okay, good. Any more? Why you are here?
NPC.
What NPC? What's NPC? What's NPC? Non-player character. Just happen to be here. Okay, good. Maybe then I will start by introducing myself and then how I view maths or viewing this world. Okay, so maybe you can go through my website a bit. Okay, so I'm from Sarawak, Malaysia. Okay, so I study in the Chinese school, primary school, and then I go to English school, and then I go to Malay school because I go to matriculation. So basically, I like learn 3 languages. Yeah. So then after matriculation, right? It's very sad because of our education system, because there's a quota system here, meaning they have to allocate some numbers of students to the Malays or the Bumi, so that I don't get my preferred course. I don't get my position that preferred in government university like USM, UPM, whatever. And so I went to ANU to study. Okay, so ANU is in Canberra. Canberra is in Australia. It's in the capital of Australia, in between Sydney and Melbourne, if you know about the 2 cities. Yeah. So I studied there for 8 years, 4 years for degree. We got 3 years degree plus 1 year of honors, like your FYP. We write thesis, and then I continued my PhD there, with the same supervisor. So I spent around I guess now it's like 1/3 of my life in Canberra. So actually Canberra did a lot, change a lot of my values on how I see things, how I view this world in particular. Yeah. Later I will share with you my math journey more detail. Then other than that, I do play music, badminton. Nowadays I train once. So if you play any of these, you can contact me. Yeah. So if you play any of these, you can contact me. We can play together. But then why I like maths? why I like maths is maybe during my childhood, right, I played a lot of Lego. So I have these pieces and then piece them together. I like to build symmetry stuff. For example, ship or airplane, something like that. Symmetry, left and right is the same. So I like these symmetric stuff, and then I like to play with structure. Right. Okay, but more importantly, I feel that this world is governed by some rules. More importantly, I feel that everything have rules. Yeah. So in Chinese, maybe they believe this is something called Taoism. Tao. Yeah. I believe there's some rules that govern this. In particular, in mathematics, you'll see a lot of rules, right? Leibniz rules, all sort of formula and stuff, right? So I like them a lot because I feel that there's just one line, but then there's infinite thing you can control. Right? Okay, so this is what I like about maths. Um, yeah. So maybe I can start with talking about the idea from my thesis first. Then maybe slowly I can talk to you what's the journey. Because basically this thesis I it's kind of like a product of 28 years of education. This is what I feel about my thesis. So in my thesis, right, I write three language poems, like to reflect like what I have learned throughout my 28 years of education. Yeah, so maybe I can read a bit. So first part is so 28 right，28数字含床壁，数算真相这美妙在，同调代数论拓扑，世界万千皆悬殊。Okay, so I translate into English. 28 years worth of truth and beauty lie within Topos Carol algebra's echo, tick-tocking string, wearing gravity. Okay, and then there's a Malay. So if you are from Malaysian, maybe you know. Berpuluh tahun mengejar kejayaan, ilmu hisab betapa benar dan cantik. Huruf tanda mengukur garisan, daya bersatu dawai berdetik. Okay, so what's the meaning about this is, so the first two part is I learned maths for 28 years, right? So I see that there's a lot of truth and beauty lie within these maths. And then the third line is about very technical about stuff. So what I learned was algebraic topology and algebra. Yeah, homological algebra. So algebra and topology. So you see algebra and topos here. And then the last one is, so the latest view on this world is, our world consists of string. It's no more atoms, but string. Strings will give you the frequency that the atoms need. So we think that string theory works, but it's not proven yet. But there's some truth lie within, I believe. But although we haven't discovered the real string thing, but then there should be something there. And why I say so, because my research is actually doing some string calculus. Yeah, so really we are working with string. Yes, okay. Yeah. So yeah, so which direction you want to go? Do you want to go a bit further academic, or you want to come back a little bit on my struggling? Which one? You want to change? Struggle a bit, okay? Struggle a bit and then we come back. Okay, so basically I have the same feeling as you when I go to university maths in first year, because it's not like you do like 100 questions then you know how to do the exam question. It's not like that. So what's worse is in my university level, right? A1 in the first semester. So meaning I do epsilon delta. So you guys who teaching you did he do epsilon delta? Just easy one. Okay, yeah. So in my first year, they already start require us to like fully understanding and then can write proof and stuff. So you could imagine that we never write proof before. I don't even know what is contradiction. Like the square root 2 I teach in number theory. I cannot understand, that time when I was like 21 years old. Correct? No, 20 years old or 21 years old, first year. Yeah, I cannot understand. I cannot understand what the contradiction is. Until like third year, I can appreciate, epsilon delta, what is it? So I think everyone will suffer a similar thing. So that's why we encourage the student to do this kind of study groups. That's why there's a study group. There's 3 years ago when I first came, there's nothing like that. So I push the student to do it. So that's why you can meet your senior. A senior can help you like that. Okay, because how they went through stuff, I hope that you can benefit from them. Yeah, because otherwise you will just keep repeating. You think very hard, but in the end you still graduate. So we hope that you don't work in suffer, so that someone can help you. They've gone through this, they know how to help. So next time you go to second year, third year, you help them. So you take turn. You understand or not? Okay, so you learn, you help, you learn, you help, you learn. Okay, so but then even in that sense, until before finish PhD, only I understand how to really do study or research. Okay, so how do I know it? That's the time when we have MCO, lockdown, COVID. Okay, we cannot go out. I don't do tutor anymore. So I just read a bunch of that paper, keep reading only. Okay, read until the stage that you feel that, I found the foundation. Did you read until this stage or not? If not, not enough. You need to read a lot. Read until you think that, this part I really understand. Yeah. This is without help. So you might think that, learning maths without help very alone. But that's very true. You have to go through that process sometimes. Okay. So this will in turn help you to understand knowledge, first of all. Second is you will understand argument better, actually. Okay, it's very important. So when people talk to you, what's their motivation? What's they trying to convey? Can you get it on? Okay, so I can tell you, you can study until a stage, right? You can understand the context that people are trying to tell you. Because you need to think about it. Logic, what's logic? I tell in the number theory class, right? Logic is a line between two dots. Out of 100 things the person want to tell you, why is that thing the most important that person want to say to you? So you can start and link back the story, or link back why he think like that, why he think like that, what happened, what could happen. Okay, so when people say, do max, what you do calculation, obviously if you just do calculation, it's no use. But then you need to understand why are you doing this calculation. You understand? Then this will help you to transfer your thinking skill knowledge to your daily life. For example, I interview with the industrial supervisor, right? The industrial supervisor said, your student very good, can search things very well, can understand very well. But they are not really doing product rule, quotient rule, whatever rule, no. What they do is like data analysis. One of them is like turning Excel file into what? Forget Excel sheet into like some automated system, something like that. Yeah. No, there's no product rule, no quotient rule, no Fermat's last theorem, nothing like that. It's nothing like that. So when we introduce this theorem, right, try to think about it, why people care about it. Yeah, and then when people care about a problem, how they solve it. Actually, not just one way to solve it, actually. There's multiple ways to solve it. Yeah. Does it make sense? Yeah. Yeah. Got question? Yeah, feel free to interrupt me. Yeah, otherwise later I don't know what I'm talking about. Okay. So maybe talk about my worldview. Worldview. Okay. I write my worldview inside my thesis actually. Okay. So the slogan here is categorification is the modern approach to natural science. Okay, so if you know about natural science, right? I don't know if you know about it or not. So natural science is like a embody of physics, chemistry, bio, and maths. So in the usual time, in the old days, there's only one subject called natural science. There's no split into this. different courses. Okay, so human try to use mathematics to explain the mechanics of universe. In particular, Galileo. Do you learn Galileo before? Galileo Galilei. Okay, so he says that this universe is written in the Grand Book, which stand continually open before our eyes, communicating in mathematical language. And so we believe we can explain everything in mathematical language. But the way we state it maybe could be different, yeah, but definitely we can state it precise. Okay. Then what else? Okay. And then maybe we can go down here. Okay. So then, so Newton discovered gravity, right? But gravity is not enough to explain this world. I mean, it's enough to explain something on Earth, but not enough to explain something away from Earth. For example, it cannot explain why Mercury can evolve orbit around the Sun, okay, with certain precision. Okay, so that's why Einstein come in. Okay, so that's why Einstein come in, try to explain the gravity in terms of a piece of cloth like that, like curvature. For example, if I put this water right in this space, right, you can think that there's an aura between this water that bend the space time. Okay, so maybe you can think of like something bend around it. Do you have a cloth here? Okay, maybe like that. Okay, so you see, so you look at this bag is a cloth, right? So you can see that this bag is like, how to say? So this bag, okay, if I remove the stuff, I mean, sorry, these are things that I haven't put in my office procedure, but it's not meant to show you. Wait, okay, so you can think of this piece of recycled bag is a piece of cloth like that, right? Okay, but when you put heavy stuff into it, right, this piece of cloth will get like bent, it's bent down. The heavy it gets, it bend more. This is the space time around you. Okay? And because it's space time, right? So meaning there's an effect on the time. So when it gets even heavier, when you work around it, your time actually gets slower. See? You know or you believe? You heard before? Yes. Okay, good. Okay. So yeah, so this is curvature, and curvature is a language in differential manifold or differential geometry. Differential geometry. So yeah, so very fascinating stuff here. Okay. But then actually you might think that this ends already, but it is not. Because we can't explain black hole. We can't explain singularity in mathematics. We cannot study singularity yet. Okay, so there's more to cover here. Okay, so research haven't ended yet. Okay, so this is about my stuff here. Okay, interestingly, maybe a fun fact about me. So when I written this piece of thing, I just write it. I mean, I based on whatever I learned in before primary school, high school, whatever I learned it. But when I write this down, after I write this down, I graduated. Okay, after you graduated, right, you have an academic ancestor. You know what I mean? Like your supervisor is your academic father. Like you graduate, you born as a mathematician. You understand what I'm saying? So your supervisor also got supervisor, right? So I can form like a academic family tree. Okay. Turns out that the two names I mentioned here is my academic ancestor. One is Galileo, one is Newton. Actually, yeah. So I'm in their line. Actually, and you can try and figure out like others lecturer, maybe they are in other some famous mathematician line also. You can try and look. There's something called mathematics genealogy. You can go and search. Yeah, there's a tree. Yeah, very interesting. So you can see that I never know it before I graduate. But then this is like what I believe. I believe this philosophy, and then I work towards it, and then you get closer to it. It's very, how to say, very surprising. Very surprising. Yeah. Sometimes you can say this is like in Chinese we say 唯心论. English is what? What's English? Yeah. I never like prove or what check whatever, but then you will show slowly a bit like also another thing is called 吸引力法则. What is 吸引力法则? Law of attraction, yeah. Law of attraction. So you have a similar frequency, similar thinking, then you will attract to the similar person. Yeah, very true. Actually, this is very true. Yeah, experience in real life. Because you might, I don't know whether you experience or sometimes you think that it's very hard to get along with this person. I don't know why, but very hard. I try, but I can. Especially when you find girlfriend, is it?
Yes.
Okay, yeah. So yeah. Have a right thinking, then you will definitely find one. Okay. What else I want to share? Okay, maybe before I share some maybe technical stuff, maybe I share some ideas. Okay, maybe show these things. Maybe some ideas I show you. Okay. Let me show you some idea in mathematics. Okay. So this is something Rachel find for me. You know Rachel, right? Okay. Rachel is famous. So this item here is fractal, where you remove the middle cube. After removing the middle cube, and then you will find a few cubes again, and remove the middle one and keep doing it. Okay, this thing has apparently has infinite surface area. Okay, you can imagine that inside the cube has surface area as well. I mean inside the hole, but the zero volume. This thing I'm not sure if mathematics stuff or not. This is built by Pythagoras. This is called Pythagorean cup. There's a hole inside here. If you fill up full until certain level, the water will split out. Yeah, it's called a greedy cup. So if you get too greedy, then you get nothing. This is what Pythagoras will tell you. Okay, but this one is. Should I talk about this? Okay, talk about this. This one, yeah, this one very interesting. This is called a Pythagoras staircase. Okay, maybe you see like this. Actually, this is not meant like this. You should see it in this way. I'm sure can everyone see it from this angle. Can you see like the staircase is like connected and then forever upward? You have to see from a certain angle, until these two can mesh out together. Then you see it as increasing always. Okay, this is called Penrose staircase. So it's just an idea, but then in 3D you can only make it. I think this one, is a calculus 2 stuff. If people can go start with this. Yeah, the constant curve. People can answer. But then this one is very interesting stuff. Maybe I can show you what's the construction thing. Okay. In mathematics, you'll learn something called stereographic projection. Have you learned in first year or second year? Okay. So maybe later you will learn this. What's the stereographic projection? You take a sphere, okay? You take the North Pole, and then draw a line through every point on the sphere. Extend it to a 2D. Then what this map doing is, without the north pole, every point can be projected down to 2D. Can you imagine? Okay, then we can even write down the formula. Actually, the formula is not too hard. It's something like this. Yeah, it's a straight line map. The straight line map. Okay, so actually we can show it using this stuff here. Maybe someone can help turn off the light. Someone help turn off the light. Enough. Okay, maybe people want to come up and see. Yeah. Come on, you can see it. Okay, so you can see it. So this light, you can think of it as this light ray here. This light ray here. Okay. So I shine from the top. You can see the changes of the shadow. See the pen? Maybe not flat enough to find the right angle. See it? Yeah. Okay. Almost. Can you see? Can you see a pen? Yeah. Can you see a pen? Yeah. Okay. So this is what this map is doing. So you turn the sphere into a pen. I mean the sphere without a point. Okay. Yeah. Very nice stuff. Okay. So what this says is actually, what is a sphere actually? Sphere is just a piece of cloth, and then you wrap it around. That's it. Hey, this is very normal. You eat bao or not?
Oh.
You eat bread? I mean Chinese bread. The bread, how is the bread made? You make it round first and then you put the meat inside and then you correct? This is the stereographic protection. Yeah. Yeah, Max is everywhere. It's just that how you view stuff. Are you are you tentative to these stuff on? Okay, good. Is Max fun now? Yes. Okay. Cool. Okay, then I still have half an hour, huh? Okay. So maybe let's talk about category then. Okay. So I mean, when I teach linear algebra, I like to tell this little tale here. I like to tell this little tales here. So, what's number actually? What's number to you? When do you first learn number? Counting. Who is the first person who tell you how to count? Mama. Others then? Kindergarten, solid. Maybe someone would say Papa. I don't know. So how they tell you? How do they tell you? 明显. Or you use finger? 明显 Use what? Got 忘记了 okay. How about the rest? Huh? Arbitrary stuff. Random stuff. Can you give an example? Good, very good examples. Hyper. Correct, true, very true. So why you never ask a question? Why you never ask a question? Did you ask a question? So okay. So why this is one, this is also one. Are they a different one? It's the same one? How are you so sure? One is apple, one is chicken. It's the same one. So what's the idea you abstract here? What's the idea you abstract here? You need, how many of them? Okay, so you are doing bijection between them actually. You are doing a bijection between them. For example, if I draw another apple here, any bijection between these two? because here we got +1 already. There's no bijection. So there's a map. We are doing a map. We are projecting a apple to a chicken. Now got 2 apple, 1 chicken, cannot project already. 2 things gonna send to 1 thing, not injective. You learn injective, right? 1 to 1, not 1 to 1 anymore. Okay. Okay. So then in this case, in this case here, okay, we want to do more than this. Okay, I want to do more than this on the category theory. So what's better about the category? Okay, maybe some definition here. Text cannot run away from definition. So a category basically consists of 2 things. One is called objects. Okay, maybe it's a set of elements, objects. And then second is called maps or function. Or morphism sometimes, but maps is fine. Okay. So satisfying some property and maybe it's not important for today. Okay, some properties here could be a composition and stuff like that. Okay. So there's a lot of category that you have know already. Okay, there's some category that you have know. So maybe I write down some examples. First of it is a category of set. So how do you imagine this? So this means that the objects are sets. And then the maps are obviously the set map. You know what set map? You know? I think in calculus 1, I taught them about function, right? You have input, you have output. Okay, I give you one set, then you can define a rule that go to another set, right? So this is a category of set. So I mean, for example, you can have real numbers, right? Then your calculus 1 will be staying with this function from real numbers to real numbers. Okay. Another thing you have learned also, category of vector spaces. This is your linear algebra. So the objects here is the 10 axiom stuff. Is it crazy? The 10 axiom stuff. Okay. The thing that satisfies the 10 axiom, vector spaces. And then maps. What's the maps in between them? You learn what? TU plus V equal to TU plus TV. TCU equal to CTU. What's that? Linear maps. These are the linear maps. Okay. Yeah. So you need to satisfy this property to have map things. If you go a bit further, maybe any second year, third year students. Second year, okay. So maybe when you go to second year, you will learn something called category of groups. You learn extra algebra 1, right? So the objects here are groups. And then the maps here are the group morphism. Yeah, I think almost there. Okay. So what can you see here? This map seems like pair with these objects. So these maps kind of preserve the structure of these objects have. Okay. Like for example, vector space have the 10 axiom. What are the 10 axiom? Close under addition, close under scalar multiplication. Then this map here will preserve those things. Okay. And then groups has closed under composition. Then group morphism will respect that. Txy equals to Tx times Ty. T identity goes to identity. Yeah. Okay. So what's the categorification here? So for example, maybe I'll give you a slogan here. Category of set, category set categorify natural numbers examples. Okay, so what do I mean by that? So if I give you a set, there's one operation you can do, which is taking cardinality. So I'll try to write it, taking cardinality. So meaning you count it. Okay, so what are the possible number you can count? Maybe there's nothing there, empty set. There's one thing, 1 point set, singleton, 2 things set, 2 apples, right? Just now I have 3, 4, 5. But you never get negative. Okay. So you can see that in numbers, right? What are the structure between numbers? What do you know about numbers? Maybe you can just say that which one is greater than which one is equal to which. Okay. But then in set is different. Okay. So maybe I can have a set of 2 apples. I can have an empty set. Empty set is unique, so nothing to say. Maybe I can put 2 person inside here. Right. But then these 2 set is not equal though. If you count it right, it's the same number though. So what happens here is we can read 2 differently. And then sometimes these 2 set here has some relation. Sometimes these 2 set have relation. Okay, so what do I mean by that? Well, so you can see that these 2 set, this 2 number 2 is the same, right? Okay. But then I can also have a bijection here, right? I can do a map, define bijection here. How many type of bijection I can define? Let's say this one is apple 2, apple 1, apple 2. This is first person, second person. How many bijection I can make? 4. The 4. 2. 2, right? Okay. So you can see that there are 2 possibilities here. Okay, so either you send 1 to 1 or you do opposite, right? Opposite. Okay. So there are 2 possibilities here. There are 2 kind of bijection you can make here, but there's only one kind of equal here. So meaning what? We put more structure on this natural number. Okay, so this category of set give more structure to it. Okay. Yeah, this is what we mean by categorify. We give meaning to this number 2. So far so good? Also good? Yeah, good. Okay. So we want to upgrade these things here. We no longer do this. We want to go something topological. Maybe let's go into knot theory. Well, maybe it sounds very scary or technical, but then really well, we have a knot here. Maybe I can get this done. Okay. So well, let's imagine I stick this thing to this two end together. Okay. So this is what we call a knot. There's no what I say? There's no battery. So okay, I think better I put back. Choose a different one. Do I have a different? Do you have any wire that I can borrow? I didn't bring my shoe that today. I have a wire. Okay, short one again. Okay. So we will say that this is the unknown. It's obvious that this is the unknown. There's no Chinese we say 几 English what we say not. Okay, unknown. There's no not here. That's why we say unknown. So what do I mean by unknown? Maybe you can fix it like this, right? And then you close it. Okay, so this is the first non-trivial knot. Non-trivial knot. Well, I mean, like you kind of show snakes every day. You see everyone wearing shoes, right? These are not. So what can you do with knots? You can twist it around, right? Without changing it. This is basically not. Okay. Okay. So if I give you a knot, can I draw a knot? Let me try. I haven't drawn these for a long time. This is a knot. Okay, this is not a knot. This is two link. This is a link. Okay. So what can I do is I can associate these to some polynomials. Okay, so what do I do here? Okay, what do I do here? So I can replace this crossing here, okay, with some operation. Look at this part here, maybe. Okay, look at this part here. I won't give you not definition. I just show you what I'm doing. It's not precise either, so bear with me. So there's two ways to open up this crossing. There's two ways to open up this crossing. Wait. There's two ways. Okay. So one way is you open sideway. The other way is you open top and bottom. Does it make sense? This is the two way you can resolve this crossing. Okay. But then because these two different ways we want to differentiate, right? One of them maybe we multiply by a q, the other we put a q inverse. So that I can say that we go different way. Good. Okay. So did you notice that? What did you notice? So really, then I think pretty much we are done here. So here is just an unknown. I can just twist it around. It's the same. I'm not without breaking it. I'm not breaking it. Just now I'm breaking. So that's why I put a grading. We call it grading here. Q and Q inverse. I'm breaking it. But now I'm not breaking it. I'm just twisting it in a 3D space. This is allowed. This is what we do just now, right? We can twist it. Here also we can twist it. Okay, so we get something like this. So let's say we put this knot here to be equal to 1. What I get is a polynomial in terms of Q and Q. Okay, this is something what we call a Jones polynomial. Okay, good. Good. Okay. So if you give me any knots, I can do this resolve for you, resolution for you. I open up right, left and right, or I open up top and bottom until I get a bunch of circle like this. Okay. Good. Then this is what we call invariant actually. This is invariant. So what do I mean by invariant? Invariant meaning if I do the allowed twist, so meaning let's say I twist something like this. Can you imagine that this two is the same if I twist this part back? Okay, so if I do this resolution on this piece of thing, I will get the same. Okay, so meaning whatever I can do here, okay, it won't affect what polynomial you can get here. So this is an invariant. Yes. Okay. So now the question is, if I have the same Jones polynomial, let's say I give you two either same or different knot, I get the same Jones polynomial. Are they the same knot? This is a very important question. So meaning if is it the kernel is trivial? Okay. So meaning would they have two different knots that give you the same Jones polynomial? It's very important. So the first question is whether, so to solve that in general, we can ask a simpler question is, do they have other non-trivial knots that give you this Jones polynomial of is one that is not an unknown? Let's say the unknown has Jones polynomial. Is there any other unknown? I mean, different knot other than unknown that has Jones polynomial 1. So you could imagine that, oh, I open out this Q inverse, and then somehow they cancel out, become 1, but it's not an unknown. Is it possible or not? This is a big problem. Okay. So I think to date, they still cannot solve it for Jones polynomial. But then what we can do is, we can associate these objects with some category. Okay, so previously you think that this n here, okay, is categorified by this set here, but then from here we can associate this state, okay, these are called state, with some vector space. I mean, there's some rules, okay, we use vector space to play. Then after categorify, okay, after taking things called point correct polynomial, in this sense, like taking cardinality, like counting with gradings, we can get this Jones formula. Then in that case, we can solve the problem. So in the category world, okay, that word actually is called the Kovanov homology. So there's a way to associate this state, okay, with some vector space here, okay, maybe some vector space. And then when you do the dimension counting with this grading here, is the same as the Jones mononomial. Then in that world, okay, the Kovanov homology of the unknown is unique to the unknown. And so meaning there's no other knot that share the same Kovanov homology as that. So in that world, this unknown problem, the invariant of unknown is unique. Okay, but in the Jones polynomial world, we're not sure. So meaning in that world, we have more structure. There's more error in between things. So meaning there's error between the state. Okay, so my research is rooted from this idea here. Okay, my research is rooted from this idea here. So this is just the introduction stuff for my research. So what I do is, what do we do? Yeah, okay. So, so my research actually is based on something called zigzag algebra. So basically, what I want you to imagine is there's this function, this. Do you know function this? This will pause. Okay, function. And then between these two, you can build a string. You can build a string. So what you can imagine is between these holes, right, you can permute them. And let's say I permute these 2 points, what will happen? Let's say I permute it counterclockwise. Imagine, twist it around. So you get longer. Right? Make sense? Okay. Yeah. So this permutation is what we call a break action. Okay. So what this action means is group action. So there's a group acting on the set here. Okay, it's a group action. So this is a break action. So you can see that these things grow longer. So you can think that you can permute any way you like, such that you see the string maybe can get longer and longer and longer, and twisting around some function like that. Okay. So what we did was we don't invent, but someone invent algebra such that we can associate these objects with algebra. So let's say this is P1. Then this will be something like P1. Wait, let me think. I think this one is P2 to P1. Then there's some break operation. Let's call it sigma. Okay. So we turn. So the thing that I want to tell you is we kind of turn topology into algebra. Okay. So because you cannot tell, I mean, okay, maybe nowadays can. I don't know about AI. Maybe AI can process image faster now, but the usual day, right? Our computer will prefer something in digit or algebra, right? So if we turn this topology problem into algebra, right, this make it a computational problem for computer. Okay, so instead of looking how we play around with this surface, right, we can use algebra to see how this curve get changed. Okay, can you see that this thing here is a bit longer than this as well? Okay, yeah. So the tool here is we make topology into algebra. Okay, although I really haven't tell you what's this object and then how I multiply it, but I just tell you what's the end product. Okay. Yeah, and then the zigzag algebra will come in to define these operation here. Okay. So basically, the topology of this punched this is controlled by this zigzag algebra. This is the idea. Okay, if you want to view this as zigzag algebra, also doesn't matter. I can let you believe that first. Yeah. Okay. Yeah. So basically, this is what I did for my PhD. We do this thing, we do this string stuff, topology stuff. But then, actually, it's quite how to say, what is 遗憾? What's 遗憾 in English? Regretful. Huh? PT? What's PT? Oh, PT 是可怜的。It's a shame. Shame. Not kind of a shame. Regret, I think regret. Kind of regret. So my PhD is not deal with one string. Okay, so what we did was we deal with multiple string. So instead of just one string with this function, we will fill up, we will join any two of the function together and then study this together. So can you imagine what happens if I twist this again? Do the same twist. What happened to the other points here? Sorry? Well, this point here will go to here, then I add another point. It will become this picture. Okay, so in this case here, what could you imagine is I have more P now. Okay, I have more P now. So maybe I have a P1, P3, and P5. And then here, I not only have these two, 1, I also have 2, 3. Okay, let's say P2 to P3. And then here, I will keep it as 1, 2, 3, 4, 5. So P5 here. Okay, so there's more things studied together. And there's more things together. Maybe you might think that, like, why are you studying this? Okay, so what the heck is going on here is very simple. So, well, let's say I know what's this, and maybe I know what's this. Okay, what could happen here is I can put some permutation between these three. Then what can you see in this case? This is actually a knot. Okay, by studying these stuff, right, if I compose them in a certain way that maybe you don't know now, it's what we call a tensor product. Then the topology side will become a knot again. Then the algebra side, there's some calculation following. Okay, so this is the part that I haven't finished doing yet. Yeah. So if you are interested, maybe you can study well, contact me. Yeah. So far, my FYP students or master students every one of them are studying about this area. And then this area is very vast actually. It's not just topology algebra. Actually, this is related to geometry, in particular symplectic geometry and algebra. Yeah, it's very related. Yeah. Other than that, next week, maybe next week, there's Xiamen Chinese professor coming visiting MIT. So I think I will giving a talk representing the department. So maybe I would talk more technical about this stuff if you're interested about this. Yeah. In particular on categorification stuff. Yeah, more technical. Then talking about a little bit about this string stuff. Next Thursday. I think the time is not out yet. I haven't decided my content yet either. I haven't given my title. So if you're interested, you can come and listen. But the problem here is from algebra to topology. This is what I did for my throughout my max journey so far. Nowadays, I rarely look on stuff on this. Actually, I get very, how is that, upset or disappointed right after my PhD, after my research. Actually, like what you experience, actually you study but you don't understand what's going on, basically. So I really get very tired that time. So that's why I was like spending time teaching here basically most of the time. I mean, learn how to teach stuff, how to communicate mathematics. So I taught a lot of courses here. Actually, that's what I would say requested. Usually, maybe teacher or what they like to teach whatever they have taught before. Correct or not? You know, it prepare. But then I'm not like that. I prefer to teach as many as possible. I taught calculus 2 before, and then algebra, MA1, and then what else? Uh, huh? Yeah, general topology, algebraic topology, and anything else I miss? Algebraic geometry. Yeah. So I try to like refresh myself on this knowledge at the same time, so that if I really want to go back to research again, then I can have a uh, proper background. Because I was like you, it's like one semester learn this stuff, never enough. It's never enough. Okay, so try to go back, study, and then try and learn with the students or stuff like that. So I feel that in the land of Malaysia, mathematics is kind of it's like a mathematics desert. Yeah, desert. Yeah. So people cannot appreciate mathematics. When you talk about mathematics, they'll say actual science, accounting, accounting, actual science, count money, banking, banker, finance. So pure max is very limited here actually. Yeah, even if you go to government school, it's very limited. Right. So I hope that we can build a good culture here on pure max. In particular, we have a lot of professor right coming back from overseas. They also have this kind of strict training on pure mathematics. So we hope to promote this more, to students. Definitely in class time, it's not enough for you to study. So that's why we created this extra time for you guys. For those who wanted to learn, actually, they can learn more. For those who don't want to learn, never mind. And they just want to graduate, never mind. Let them graduate. But for those who want to study, let them study more. Right? So that's why the purpose I come back here is I want to pass on the knowledge that I need. That's it. Yeah. Otherwise, I think I won't be staying here. Otherwise, I won't be staying here. But then this patient could fade very quick, you know. In particular, if you have to face reality. You understand? You like, for example, maybe your parents getting old stuff, or you also getting old yourself. There's not much time you can play around already. So when people are willing to tell you stuff or give you something, if there's not with bad intention, maybe you can try and accept it. If you can, if cannot, also never mind. I already learned try not to force people, so it's okay. I can give whatever I can, but if you don't want, never mind. Yeah. So it's not my person. I mean, only my power. So I hope that for those who benefit from whatever I taught them, please pass on, pass to your friend, pass to your after anyone that beside you. Yeah, because I alone I cannot do it. You understand? Yeah. Mm. Yeah. Maybe 8:30. Okay. One last thing. One last thing is like apart from this, just now I mentioned about calculation is not important, right? So there's some life lesson here, right? Say So I feel that logic is very important for our society. Very, very, very. A lot of communication actually come from logic problem. Yeah, so that's why even in number theory, I try to teach them contrapositive contradiction. Yeah, although it's not tested, because I want them to have the right thinking, not to confuse. Like P implies Q and Q implies P, are they the same? Because often people will think that these two things is the same, so they confuse. 你明明不是这样讲的咩？你那天不是这样讲的，不是，我就是这样讲，讲不懂啊，讲不听啊。It's very hard. It's very hard. 真的。I tell you even with the maths lecture, sometimes it's very hard to argue. Very hard. You argue with logic, they argue with emotion. It's very hard. Too hard. Okay, so I hope you study maths, you see things clear, and then maybe you can use some communication tactic. I found it very important. But then I hope you can see things clear first, okay, before you act. That's what I wanted to say, apart from these categorifications. Okay. I hope you can benefit from the sharing tonight. If a chance, maybe we can meet again. Anything you wanted to ask before we end? Q&A? Yeah, Q&A. Actually, there's one thing I haven't forget to show you. Yeah, this is a climb method. We heard about climb water before? Huh? So this time water is like a self-intercepting objects here. Okay. So I can fill up this time water using this hole. I can fill it up without dripping. Okay. Can I show you? So I try to put two balls into it, and it won't come out. Sorry. This is a fail case. Life is full of failure. Let me try it. I forget which one is the direction. Okay, but it's really a bottle. Yeah, so you need to know whether it come from here or come from here. Yeah, so if you go online search, because this is not transparent, so it's hard for you to see. But if you go online, you can know that which kind next. So if you try to I mean, you can turn it around and get it out. You want to try. Careful, the ball will move. Yeah. So this is a topological structure. You learn algebra topology, you learn how to construct the thing. We just did it last week. Yeah, Q&A. Q&A. Any question? Q&A. Yeah. 可以想一下。
它是自动加进去的。
就是 after you graduate your thesis, right? You graduate under which supervisor, and then they will add into the supervisor. Descendant of the supervisor. Maybe I can show you. I got the screenshot. Is it here? Yeah, this is my family tree, academic family tree. Very hard to see. Maybe this line. So there's like a lot of Arab coming from Arab. So this part is like coming from Europe. This part is coming from Europe. I don't know how many mathematicians you know. Right here, I cannot draw here. So I got Newton. I don't know you guys know Hopkins or not. Maybe you haven't learned yet. Kelly, Kelly graph, Kelly graph. Littlewood and Hardy, you know Hardy? I think you watched the movie of Ramanujan, right? Ramanujan. Hardy and Littlewood. And this guy is very interesting, famous in China. I'm not sure the Chinese know or not. Chen Xingsen. Chen Xingsen, yeah. Chen Xingsen. And then very close already. My supervisor. And then Igor Frankl also quite famous. Maybe it's in the modern sense, not the classical stuff. 哪一个？这个 Garland 哈 ，Yeah，有些也是两个，Hardy 跟那个 Spencer is also very famous actually. Whittaker. Yeah, if you learn more on, I guess, okay, Hardy and Littlewood is number theory. Whittaker, I think is geometry one or vector bundle stuff. Then Caddy should be group stuff and Hopkins vector bundles. Yeah. Okay. Yeah, actually, not only me, I actually have an academic brother, meaning he and my graduate at the same time. Also in Malaysia. He's from Penang. Graduate at the same time. It's very rare. It's very rare that you have a same supervisor and do PhD together. Because usually PhD is alone. It's a lone ranger. Maybe different year sometimes, but usually it's per person each batch. But very it's a very coincident. So in my website, right, I actually also put some very interesting stuff about mathematics that you can read if you like. And I also put some lecture notes based on what have I done in this university. And then they help me do this lecture note very lovely. You can have a read if you like. So the point of my lecture note is I try to make this knowledge like accessible to the locals here. It's like how you can read stuff, sometimes you pick up a textbook, right? You don't understand. You pick out that textbook, you don't understand. So when I read these notes, I make sure they understand. So they will give me feedback one. So I adjust. I put in the necessary example for them to know what is going on. Yeah. So this is the special things about my notes. If you also can read and then you can give me feedback. If I need, I can add more stuff here. For now, it's just AA1, algebraic geometry, and then general topology. Other than that, I have a written one. It's like what I did for the elementary number theory. All of it is written. It's just that sometimes they are willing to type for me, then they will type. I think the next project I want to do is MA1. Next semester I'll be teaching MA1. You have class? Your class? Okay. Be careful. Yeah, MA1 is kind of the hardest, I would say, hardest course in this school. Okay, because there's a lot of logic that you have to get it right. Other than logic, is about numbers. Something like that. Okay, but most importantly is logic. I'll make it very logical. I'll make it very definition based. I've taught it once before, not too bad. Hopefully it will get better. Any more?
The problem. Yes, I'm studying, but I don't know what's going on.
You don't know what's going on. Okay.
just a problem. I'm studying this, but I don't know what to do.
Okay, I get what you mean. Did you try textbook exercises, stuff like that? Yes? Did you try all of them? How many you try?
Some,
Some?
not all, but
Okay. Sure. So maybe I can give more specific answer. Are you coming from MAT or not? Oh, yes, okay, good. So for example, MAT problems, right? Like linear algebra textbook, for example. Yeah, I use the David Lay's one. But then there's like 50 of them. Is it correct? Questions. Yeah, behind every chapter. So the question at the back, towards the back, is more testing on understanding. So you should try those. Then after you try those, you will feel that, oh, there's something that I don't understand. Okay, this is one way. Okay, use question to test. Second way is nowadays, there's a lot of YouTube videos, TikToks, stuff explaining ideas. Like, you know, 3 blue, 1 brown? You know? You know? 3 blue, 1 brown. Okay, let me search for you. There's a lot of nice YouTube videos or TikTok. Why question? That's my. So, 3. Okay, later I tell you about my Wanzer plan. Okay. So 3 blue, 1 brown here. You see, if you look at their videos, right? Okay, they will explain. You see, but what is the plus transform? Right. So meaning in class, you learn the plus transform or transform this function, what formula, integrate, one time, multiply by exponent. But then this will explain what is the physical interpretation. You understand? Yeah. So you can look for this kind of videos. Yeah. Also, I like one of the Chinese YouTuber. Yes. That guy. I think it's a Tsinghua PhD. Months. Yeah, months computer science. Yeah, that guy is very good. Yeah, this guy. Yeah, this guy also very good. Yeah, you can have a look. Yeah. Okay, this guy also good. Okay, so you can watch these videos when you go through the knowledge. Yeah. Can. Which year are you in? What's your name? 2509. 509. 2509. Good. Yeah. Yeah, so maybe any more question? Any more? Yeah.
Elementary numbers.
Sure.
After the study of I know that I have a lot of concerns. So I chat with AI and it's turned out that there are many knowledge about the
groups, yeah.
Stuff that
Yes. Later. Yeah. So you're confused.
Because I don't have that knowledge.
No, I mean you can ask AI, say don't use group knowledge to talk to me, right?
I don't know exactly that's root is for, what the structure is. I'm just doing remember the zero.
Yes. In that case, then you really have to go to group theory, but we don't require you to understand those.
I see
Yes.
But I know I have a lot of stuff to learn.
Yes.
I'm in a rush.
Sure. But yes.
I don't want to give myself time. I just want to learn that group theory in one day. I'm in that rush.
Okay, sure. Yeah, you could do that.
No.
What do you mean? What do you mean? Mhm. Sure. Yeah.
Feel the structure.
Ah, okay. Sure. Maybe I can share you one story. Maybe one point I upset about my research is I do too much of preparation like you, but I never understand also. So it's impossible to fill up all the foundation that you wanted. So what you have to do is you just pick up what you need. That's the thing you can do. Yeah. You cannot say I have to master group theory. There's no way for you to master group theory. Even I also cannot master group theory. Even the group theory professor also cannot. Can you get the idea of understanding now? It's impossible. So don't talk about fully understand, because this is what usual student would think. What you need to do, I can suggest you, is whatever you see you don't understand, go and find direction. You accept it, good, carry on. That's it. No need to wait. No need to learn extra extension, because this extension never ends. It's like a never-ending hole. So you just fill up the hole that you need is enough. Yeah. But then you actually have a good self-study skill now, actually. But then you need to, how to say, be a bit more persistent. So if you like this a lot, but people don't stress about it, you go first. You go first. This is what make you unique. This is what make you different from the rest. Then people will have an impression say that 哇，这个人很厉害哦，怎么他会懂这些东西？Because this is what you like. If you like, you go and do. Just do. Don't care. Okay. Maybe don't too compromise with your academics, because sometimes people will like go too deep into and then they just like their result or assignment they don't do with me like that. Don't go until that extreme. But then if you really decided what you do, there is a case, right? I mean, multiple cases. For example, Bill Gates, for example, Mark Zuckerberg, they don't finish their assignment. They don't finish their degree. They earn more money than you. Correct or not? So meaning you have to get something right first. Then you can go and do it. So if you just hit and then run, then you're wasting time. So let's say, give an example. Yeah, I don't suggest you advise anything to you. I just say give an example. Let's say in your case, okay, primitive root need a group theory to understand. Okay, let's go and read a little bit of group theory first. No need one day. You don't imagine. Sometimes people are bitten by their imagination. Maybe no need one day. Maybe 5 minutes only. Serious one. You click Wikipedia group theory. What is a group? Done already. No need one day. So you just learn to the stage that, or you can understand what Gemini do. ChatGPT. If not, you can straight away ask ChatGPT also can. So okay, let me tell you what is the advantage of using Gemini is he can speed up the searching skill. Okay, he can speed up the searching process. You understand? He can search for you one. You just ask, keep asking. Yeah, he will answer you one. Gemini is very good. He speed out the search process for you. It's not that you have to believe whatever he say, but just that he can process the material very fast. Instead, you yourself go and read it. Right or not? So you need to use it wisely, I would say. It's like calculator, man. When the calculator first come out, people say calculator not good. If you have calculator, you don't know how to count already. Do you know how to count? You still know how to count? Correct or not? So is the problem that how you use it. You understand? Oh, last question. Last question. No? Yeah. Last one.
I agree that the Gemini is now is the most smartest is the smartest AI in math problem solving. After hearing your answer, I have a think that maybe when we use AI to study math, is the important point is know where to start.
Where to start?
Yes, just like okay, I will stop here, not go deep down.
Okay, sure. Yeah, sometimes you need to learn how to stop. Yeah. Sometimes you need to learn how to stop. Sometimes you need to learn how to proceed. I cannot say that this time you have to stop, this time you have to proceed. So this thing is very personal to everyone. So you need to experiment yourself. You understand? Yeah. So if you think that you go a bit too far, so step back a bit. Okay, if you really need to go that far, go a bit, and then step a bit, go a bit. Yeah. So you need to control yourself, basically. Have a self-discipline. It's very important. Okay. So why do I play Wanzi? So that day, I survey in my class, almost half of them play Wanzi. So it seems that this Wanzi game is a common language. Yeah. So if I can teach using Wanzi, then people can get the idea better. You understand? Okay. So be aware, maybe Wanzi will appear in the assignment one day. Okay. Okay. Yeah, so that's it. That's it for today. Yeah. Okay, certificate. Okay. Okay, thank you. Okay, thank you.
你们没有比赛，我们有比赛。是，我是想里面我还是这样子的。
Okay, thank you.